What hardware do you actually need to run AI locally? That is the question we're going to answer in today's video. We're going to run a bunch of large language models locally, including DeepSeek's latest R1 reasoning model on 4 different devices, ranging from low-powered devices to top-of-the-range laptops. I decided to do this test because honestly, it just got confusing. I didn't have $3,000 laying around to buy the latest graphics card, and when it came to CPU, RAM, NPUs, tops, flops, it all became too confusing. So I wanted to see how these devices actually stack up. Today we're going to be running these large language models on a Raspberry Pi 5 with 16GB of RAM, a Surface Laptop 7 which has an inbuilt NPU processor, a 2017 MacBook Pro, and an old gaming PC I built 8 years ago. We're going to run these tests using a free piece of software called Ollama. It runs on any environment and lets you interact with your large language model directly through the command line. When it comes to running these models, the main thing to consider is the parameter size. Generally, the bigger the parameter size, the more RAM you're going to need and the slower your responses are going to be, but they're going to be of higher quality. For this test, we're going to run 3 different models across all of our devices. We're going to start with a 1 billion parameter model, step it up to a 3 billion parameter model, and then finish up with a 7 billion parameter model. I would like to go higher, however, many of my devices are limited by their 16GB of RAM, which means many of the larger models simply won't load. Let's start with the Surface Laptop 7. Now this is the X Plus variant, which has the Snapdragon 10 core chip in it. It has an inbuilt neural processing unit which is rated at 45 TOPS, and it has 16GB of DDR5 RAM. I'm expecting great things from this device, so let's kick it off. We're gonna start with the 1 billion parameter model. So I'm just going to start that up, and it loaded instantly. The responses are really quick. We're getting on average above 50 tokens per second. Super happy with that. We're gonna exit out, and now we're going to run the 3 billion parameter model. It took a couple of seconds to load, so we'll see how it performs. Still really snappy, we're getting about 30 tokens per second. For the longer response, it did drop down to 15 tokens a second, but it was still very quick and usable. Now we're going to see how it handles DeepSeek's reasoning model. Now the full version is actually the 671 billion parameter set, but we don't have nearly the type of machine to run that. Instead, we're going to run a smaller distilled model, which is the 7 billion parameter set. Took about 5 seconds to load. It's still quick, but for larger responses, it did slow down to 6 tokens a second. So it's usable, but it could be better. Now we're going to run the exact same test, but on the Raspberry Pi 5 with 16GB of RAM. This is a much lower powered device with a slower CPU, so it'll be interesting to see how it handles some of the models. I'm going to remote into my Raspberry Pi, and we're going to fire up our terminal session. We'll start with our 1 billion parameter model. We can see it handles the 1 billion parameter model quite well. We are getting about 7 tokens a second. We're consistently getting about 6 to 7 tokens a second, completely usable, but the slower responses are expected because of the difference in hardware. Let's see how the 3 billion parameter model compares. Now that actually took about 15 seconds to load up. And I can see it's taking a lot longer to get the responses. It's still working, but it is a bit slower. If you're using a Raspberry Pi, you're probably going to want to stick to a smaller model or build your application in a way that doesn't rely on real-time processing. It got 3 to 4 tokens per second, which for me is just a bit too slow for my liking. So if you're using a Raspberry Pi, I would recommend you stick to the smaller models. Given it was a bit slow on the 3 billion parameter model, I know loading DeepSeek, the 7 billion parameter model, is going to be even slower, but I want to see, will it at least work? We're getting about 2 tokens a second, and that means we're seeing word by word every single second. Glad it works, but it is a little too slow. Now I will say, this is on the standard Raspberry Pi 5 with 16GB of RAM. This is without a heatsink or cooler attached. I don't have metric set up, but the CPU is probably spiked at 100% and it's probably throttling down. So if you have one of these, a cooler will help, and you can also get an AI hat. Now this will give you extra performance when it comes to AI tasks. This is the 26 tops version of the AI hat. In a future video, we'll see if we can get this performing much better on the Raspberry Pi by using these. Because right now, a couple of tokens a second on a 7 billion parameter model just isn't going to cut it. Now let's switch to the 2017 MacBook Pro. I'll chuck the specs up here for you guys. Unfortunately, this is a model right before they released the M1 chip and their unified architecture. So I fully expect more modern MacBook Pros are going to be significantly better. So just keep that caveat in mind. We'll start with our 1 billion parameter model. It loaded extremely quick. Now, surprisingly, it's extremely slow. We're getting 1 to 2 tokens a second. Even the Raspberry Pi performed a lot better than that. I was doing some digging and it appears OBS Studio, the software I use to record the screen session, which I had running when I did the test on the Surface Laptop 7, it was taking about 30 to 40% of the CPU on the Mac. So let me just hold my camera, and this is running the 1 billion parameter model. We're getting a lot faster responses, about 11 tokens a second. And with the reasoning model, we're getting about 3 tokens a second. Overall, I'm really disappointed in the performance with this device. Now, like I said, it is a 2017 laptop, which means it's 8 years old, and it was right before the M1 chip got announced. I fully expect the new Mac lineup would be significantly better. I'm hoping to get my hands on a newer MacBook Pro sometime this year, so I'll release an updated video when that becomes available. Now, finally, onto my gaming PC. I built this computer 8 years ago. It's got an old i7 CPU, 64 gig of DDR4 RAM, and it's still rocking an NVIDIA GTX 1080, which has 8 gig of VRAM. Using dedicated graphics cards and loading your AI into VRAM rather than RAM is meant to be significantly faster, but I'm very interested to see how this performs given it's on a graphics card that is about 8 years old now. As expected, it's extremely fast. We're getting over 90 tokens a second on average. Now let's try the 3 billion parameter set. Again, it's extremely fast. We're getting over 50 tokens a second. Let's run DeepSeek's reasoning model. Now the first response is really quick. We got over 30 tokens a second, and again, very close to 30 tokens. That is amazing to see. I love knowing that even a GPU that I purchased 8 years ago is still able to outperform even the latest. Just because I'm curious, on this machine, we have 64 gig of RAM, so I'm gonna try and load a 70 billion parameter model. Now, this would not run at all on any of my other devices, but because we have the RAM, in theory, it should load, but it'll just be extremely slow. That took a good 30 seconds to load up. It's taking a very long time to think, but it appears to be working. We're getting less than a word a second. It is working, but very slow. I'm gonna speed this section up. Less than a token a second. That was pretty cool and actually really insightful. So what we learned, graphics tops everything. You can still get better performance. Even running old graphics cards that you purchased 8 years ago, like the 1080, that still outperforms the latest devices running CPUs with NPUs and all the works. If you're running models on lower powered devices, such as the Raspberry Pi, you are going to be restricted to the smaller models if you want a timely response. And when it comes to Macs, even though I experienced disappointing results on my Mac, I'm sure the newer ones with the M series chips and unified architecture would perform significantly better. I will post a follow-up once I get my hands on one. So I hope that gives you guys kind of an indication of what you can run on your own hardware. Thank you so much for watching, and I'll catch you in the next one.